Okay, so we have a ratio of 3 to 2 to 2 to 1. Now, we have 8 hydrogens in all. So you start by working out EOUs. And EOUs are 1 plus number of carbons minus half of H plus halogens. Now, we don't usually have many unknowns with halogens, but in this case, we have chlorine. So this is 1 plus 4 minus a half of 8 plus 2. So that's 1 plus 4 minus 5. So that's equal to 0. So we have no double bonds and no rings. We just have a straight chain, no double bonds. All right, well, this is the first unknown. So the integration ratio for the hydrogens is 1 to 2 to 2 to 3. We have 8 hydrogens in all. So if the ratio is 1 to 2 to 2 to 3, that means it corresponds to 1H, 2H, 2H, and 3H. So we have a doublet at 1.6 ppm. And that's 3 H's. That gives us then a CH3. We know that because it's 3 H's. The integration is the most important thing for helping you figure out what your unknown is in most of these cases. By the way, we have 4 peaks in the carbon-13. That tells us simply that we don't have a lot of symmetry because we have 4 carbons in all and we have 4 types of carbon. So each one is different. There's no symmetry involved. And since there are no double bonds, you'll notice they're all to the right of 100. Okay, so the next 2 things we have, they're clean peaks. And since we have no symmetry going on, they must be CH2s. Okay, so we have a CH2, another CH2, and then the other peak is a CH because it's got only 1 hydrogen on it. We don't have any OHs here to worry about, so and OHs are always broad singlets anyway. So, what we've got to figure out now is where to put these pieces in such a way that we can position the chlorines correctly. Now, clearly we have a CH2 that's quite upfield. It comes at 2 parts per million. But then another CH2 is at 3.8 or so. Now, if you look in the table, and the table actually says for CH2Cl, 3.6 to 3.8. That fits perfectly with that CH2. So we know one of our CH2s is next to a Cl. What about, where's the other Cl? Is it attached to the CH, the CH2, or the CH3? The CH. Because the other downfield peak at 4.3 is a CH. So we can say we have that peak there. All right. So all we have to do now is we have a jigsaw puzzle that has 4 pieces to it. And I'm going to call those pieces A, B, C, and D. So I'm going to try writing those. We have to have CH3 at one end, and we have to have CH2Cl at the other end, because those, as long as you follow the rule that carbon forms 4 bonds, it has to come at the end. All right, so we can either, so this is A and D. We can either have go A, B, C, D. Or we can do A, C, B, D. So how are we going to figure out what we have? Any idea?
That is based off of like the multiplicity.
Right. So our CH3 is a doublet. That tells us we have one neighbor to the CH3. So this one has 2 neighbors. This CH3 has only 1 neighbor. The other characteristic thing is this peak here, that's our CH2Cl, that's a triplet. That's telling us the CH2Cl has 2 neighbors. It's next to a CH2. This one has 2 neighbors, so it fits. This one would be a doublet. So this peak would be a doublet, not a triplet. So therefore, we can say this one is wrong, and this one is correct. So that's 1,3-dichlorobutane.